am Hanamis Sampit.
I am Joanna Marie Mata.
We will discuss our topic on water phase transition.
So grab a pen and paper and do note-taking. Enjoy!
We will go through the topic using our study guides as shown on the screen. I guess you are ready. Let us begin.
Have you ever wondered why boiling happens when you heat a pot of water? How about when you place a cold drink on your table and see water droplets in it? Well, this phenomenon is called a phase transition. A phase transition is a change in state from one phase to another. Phase transitions occur when sufficient energy is supplied to the system or a sufficient amount is lost. For example, when a pot of water is placed on a burner, it will soon boil. The heat is providing enough energy for the water molecules to overcome the intermolecular forces. The liquid water will transition to gaseous water or steam. Two factors contribute to phase transitions: the temperature and pressure. Heating a liquid increases the speed of the molecules. When there is an increase in the speed of the molecules, they compete with the attraction between them and cause them to move a little apart. On the other hand, cooling a liquid decreases its speed. The molecules get so cold that they slow down enough to hook onto each other, like liquid water forming into a solid crystal. Often, when you're asked about a phase transition, you will need to refer to a phase diagram to answer it. A phase diagram is a visual representation of how a substance changes phases, like melting, freezing, evaporation, condensation, sublimation, and deposition. This time, let's talk more about the amazing states of water. Under normal conditions, water exists in three phases: the solid phase or the ice, the liquid phase or the water, and the gaseous phase or the water vapor. Perhaps you're wondering, how does the water cycle change states?
The sun plays a major role in providing energy to power the water cycle. Water is self-renewing and continuous. It does not need an external stimulus to change its position or behavior. When water changes state in the water cycle, the total number of water particles remains the same. All changes of state involve the transfer of energy.
Let's break down these stages. The water cycle begins with the evaporation of water from the surface of the ocean. As moist air is lifted, it cools, and water vapor condenses to form clouds. Moisture is transported around the globe until it returns to the surface as precipitation, whether rain or snow. Once the water reaches the ground, one of two processes may occur. Some of the water may evaporate back into the atmosphere, or the water may penetrate the surface and become groundwater. Groundwater either seeps its way to the oceans, rivers, and streams, or is released back into the atmosphere through transpiration. The balance of water that remains on the Earth's surface is runoff, which empties into lakes, rivers, and streams, and is carried back to the oceans, where the cycle begins again.
Phase transitions of water are essential to understand for applications such as engineering and building design. For example, the well-known and destructive heaving of concrete roads and footpaths in winter is due to the phase transition from water to ice under the concrete. Talking about water's phase transitions, humidity also plays a huge role. Humidity is the presence of water vapor in the atmosphere. The more water evaporates in a given area, the more water vapor rises into the air and the higher the humidity of that area is. If water didn't evaporate, we wouldn't have clouds and it would never rain. This time, let's look closer at the formation of clouds, rains, and deserts. Clouds are formed when the air contains as much water vapor as it can hold. It is called the saturation point, or where the relative humidity is 100%. When saturation occurs, moisture becomes visible water droplets in the form of fog and clouds. Rain occurs when the relative humidity is so high that condensation forms, known as supersaturation. Supersaturation indicates the amount of excess water vapor available to form rain and snow. It is where precipitation takes place. Deserts exist where there is extremely low relative humidity or extreme subsaturation. When air is dry, it will exchange heat more quickly than it contains more water vapor.
As the air reaches its capacity of water vapor, the excess spills out as liquid water. The capacity of air to hold water vapor is called vapor capacity. As air warms, its capacity for holding water vapor increases. As it cools, the capacity decreases. The condensation of water vapor requires a condensation nucleus, something to which water molecules can attach. Salt is an excellent condensation nucleus. It explains the predominance of haze and fog along sea coasts. The transition between the vapor and liquid phases of water depends on the balance between condensation and evaporation. Consider the air over a lake. It is constantly taking water molecules from the lake or evaporating and giving water to the lake through condensation. During a phase change, there is energy formed from the heat released or absorbed by a substance. It is called latent heat. It is acquired as it moves from solid to vapor through melting and heating. As water vapor condenses, it releases latent heat and the air around it becomes warmer. Latent heat from condensation causes an increase in air temperature surrounding the water droplets. As more water vapor condenses, cloud volume increases and the chance of precipitation increases. As we all know, the vibration of the atoms plays a crucial role in a phase transition. There are three important ways of measuring temperature. First is the dry bulb temperature or the regular temperature. It is a temperature that exists when air is subsaturated. One can think of it as dry air, where the relative humidity is 100% around the mercury bulb of a common thermometer. The second is the wet bulb temperature. It is a temperature measured for saturated air under conditions of evaporation. A crude way of measuring moist bulb temperature is to wrap a thermometer's bulb in an E-fed cloth and blow air on it. Latent heat is absorbed by the evaporating air and drawn away from the thermometer. Last is the dew-point temperature. It is a temperature at which vapor begins to condense, creating fog. Further cooling becomes increasingly difficult because it contracts vapor capacity, creating supersaturation. Supersaturation leads to condensation or dew and to the release of latent heat that warms the area. You might have thought that adding more heat increases the temperature. Well, you are wrong about that. Temperature increases linearly with heat, but the heat added does not change the temperature. That heat energy is used to break intermolecular bonds or the hydrogen bonds in water. There is no temperature change because there is no change in the kinetic energy of the particles in the material. The energy released comes from the potential energy stored in the bonds between the particles. It is quite a long story, right? The next time you'll see water droplets in a cold drink, remember that it's because of a phase transition. Well, in our daily living, more instances show phase transition. You may not notice it, but it's really happening. We do hope that you've enjoyed and learned a lot. Don't forget to drink water as you may be dehydrated from the topic. See you next time. Bye!